Okay. All right. So when we're talking about independent variables, this is also going to be something where we use other words like input. Our input is an independent variable. These are always our x values. And we can also call it domain. Our dependent variables, these are our outputs, which are our y values. And we will call this range. Are these words familiar from 6th grade?
Yes, they're very familiar.
Yeah.
Good. So then when we talk about rate of change, which is something we kind of talked about a little bit before, it is how the dependent variable, which is y, changes in relation to the independent variable. We actually use the letter m to represent our rate of change. And we can shorthand it by saying this little triangle, which means change. Change in y over change in x. Have y'all seen the little triangle before?
No.
Okay, this will be new.
Yes.
All right. So then we look at how we can represent multiple representations. And it's actually in 4 different ways. You'll have your graph, which is obviously, on your coordinate plane. Would that graph be proportional that I just drew?
No,
Why not?
Oh.
because the
Not going
line
to the origin.
doesn't start at the origin.
It does not go through the origin. Very good. All right, and then we can represent it with equations, which is that equation that we just talked about. So that's going to be our y equals mx plus b. So remember, this is combining multiplicative and additive. We have our tables. Does it always have to be straight up and down?
No, it could be like side or top and
Okay.
bottom.
It could be top and bottom. It could also look like this. Good. And then our problem situations, these are just our word problems. So we can represent linear relationships in 4 different ways, these 4 different ways. So this first part of the equation, this m, that is our rate of change. It's how quickly our independent variable is changing. Remember, rate of change is our change in y over our change in x. This b is what we call an initial value, or a constant. We call it our constant because it's a number just by itself. So if I have y equals negative 3x plus 2, what is my rate of change right there? If the coefficient, the number in front of my variable, is always my rate of change, what
Okay.
is my rate of change over here?
-3 and the 2.
Now the negative 3 would be m.
Yes.
What would the positive 2 be?
B.
B. Good. So if I have a negative rate of change, do you think my graph is going to be increasing or decreasing?
Decreasing.
Good. So it'd be going down. And this positive 2 also tells me that it crosses my y-axis at 2.
Mm-hmm.
Do you have any questions about this so far?
No, it's pretty straightforward.
Awesome. Okay, so now we look at our table. We have time and we have distance. I want to know which one is my independent and which one is my dependent variable. What do you think?
Okay. The numbers on the left are dependent, and the big numbers are independent.
Well, let's think about it. We have time and we have distance. What depends on what?
Oh.
I think the first time is independent and then distance is dependent.
Yeah.
Okay. So does distance depend on time? Does the distance that you travel depend on how long you're traveling?
Yes.
Mhm.
So this would be our X and this would be our Y.
Why? Yeah.
Yes.
So then now knowing that, which one is our independent variable?
Distance.
The hours, time.
Hours.
Our hours, because X
Oh.
is always our independent,
Oh.
which would make our distance our dependent. So if I asked you to list out the independent values, what numbers would those be?
2, 3, 5, and 6.
Very good. 2, 3, 5, and 6. Notice I am just listing out the values for X. What if I wanted to list out the values for Y? What if I wanted my dependent values?
90, 135, 225, and 270.
Does it make sense where Charity's getting these numbers?
Yes.
Good. Okay. So now let's look at our bottom equation, our bottom table. We have time and we have the water used. So what depends on what here?
The water usage depends on the time.
I agree with that. If you think about like how long you've been washing dishes, the longer you wash dishes, isn't that the more water that you use?
Yes.
Mm-hmm.
So then which one would be X here?
Time.
And then
Okay.
so water
Water
used,
used is Y.
Why?
right? So then for this bottom table, what would my independent quantities be?
1, 2, 3, 7, and 10.
Good. So I could list these numbers out right here in set form, just like this. So then what would my dependent quantities be?
5, 10, 15, 35, and 50.
Very good. Very good. All right. And I want to talk a little bit more about something else. Delete all this. When I'm looking at a table, I can find M, which is my rate of change, or my change in Y over my change in X, by looking at the X and Y values. So from 90 to 135, I increased by 45. On the other side of the table, from 2 to 3, I increased by 1. So I can put 45 over 1 to get my rate of change of 45. If I look at 135 to 225, I see that I increased by 90, but my X's increased by 2. So here my change in Y was 90 and my change in X was 2. But 90 divided by 2 still simplifies to 45, which means I have that constant rate of change.
Stop.
Y'all have any questions about that?
No.
No.
Any questions on that one?
No.
No.
Awesome. So then here on this bottom one, what was my rate of change? How do I get from 5 to 10?
Add 5.
You multiply by 2, or just add 5?
Yeah, we'll go to 2, but
So if
Add
you want
5.
to, yes, you are correct. You would add by 5. And then here you would add by 1. So that change in Y would give you 5. But notice that's the same value that you would multiply X by to get to Y. When we think of calculating rate of change, when you think about how something changed, you think it either increased or decreased. So for rate of change, think addition and subtraction. When you're thinking about proportional relationships, think about multiplication and division. So the fact that I can go from time to water use down here by multiplying, does that mean that this is a proportional relationship?
No.
No, but it's not 0 and 0, so it wouldn't be the origin.
It doesn't start at the origin.
Well, let's think. If I have 0 minutes, how much water did I use?
Oh, 0, so it is purple.
So even though you didn't see the 0, 0 in the table, it is still that proportional relationship because this is multiplicative. After I multiplied, did I have to add or subtract anything else? Or could I get straight from time to water by multiplying by 5?
We can get straight to time water by multiplying by 5.
Good. So this would be proportional because it is also multiplicative.
Okay.
Okay, and then we can look at a graph. I don't know how to get rid of my face. Here we go. All right, so we have our laps completed and we have our time in minutes. So if I want to label this coordinate plane right now, what variable would time in minutes be?
3 and 2.
What variable would I use to show that?
Oh,
Time in minutes. So which one would be X, would be Y?
time in minutes is X, and then laps completed is Y.
Good. So then when I want to come list out my independent quantities, what numbers are those? Let's look at our points. We have this point right here, this point, and this point. So for those particular points, what are the X coordinates of them?
3, 6, and 9.
Yes, and you are missing 1.
2.
What's the X coordinate for the point at the very bottom?
0.
Oh, 0.
0.
0, 3, 6, and 9.
0, 3, 6, and 9.
And the
What
bottom would be 0, 2, 4, and 6.
And
Oh,
0, 2.
2, 4, and 6. Yeah.
So our independent is always X and our dependent is always Y.
Okay.
You can also find your rate of change from the table by saying, still thinking our change in Y over our change in X. So if I draw a right triangle from one point to the other, if I look at the change in Y, so it'd be this horizontal piece right here. That went from a 2 up to a 6, or excuse me, up to a 4. So how did the Y change? It increased by what?
2.
It increased by 2. Good. And then my X went from a 3 right here to a 6. So how much did that increase?
3.
So then my rate of change for this would be 2 over 3. And if you think about it, you can stair step up. So every time I'm increasing by 2 and I'm running over 3. I increase by 2 and I run over 3. I go up 2 and then go over 3. Do you see how every time that finds me that at points that are on my line? You see how the stair steppers are how much your Y increases and how much your X increases?
Oh, yeah.
Mhm.
Yes, I did.
Good. Next one. Could I also make a table out of these?
Yes.
So if I make my X and Y table, the first one would be 0, 0, which means this is what kind of relationship?
Proportional.
Very good. And what's the next point that I would put in there?
3 and 2.
0, 0, 3, 2.
6, 4, and then 9, 6.
Good. And if I wanted to make a word problem, could I say that I run 3, I can complete 3 laps in 2 minutes? Is that what that point means right there? Or it takes me 3 minutes to complete 2 laps? Because if you have this point 3, 2, 3 is your X, which is your time in minutes. 2 is Y, which is your number of laps. So this tells me I can complete 2 laps every 3 minutes. You see how this tells us, this one graph tells us so much information. Questions on that before we move on? No? Right now we have a verbal situation. So a baker can use 2.5 cups of flour for each cake he bakes. So if I want to make a table, I have cups and then, or I said cake and then flour. What do I know about the cakes and the flour?
It uses 2.5 cups to make a flour for each cake.
Oh yeah, oops. For 1 cup,
It takes 2.5.
2.5. Well, what about for 2 cakes?
2 point. Oh, okay, for 2 cakes, it would be flour. Oh, it'd be double that. It'd be 5. 5
Good.
cups.
What about 4 cakes?
10.
Good. So to find the total number of flour you need, you would take the number of cakes and multiply it by 2.5. Do you see how I got this rule right here?
Mm-hmm.
And is this multiplicative or additive?
Additive.
Are we adding or subtracting anything?
Oh no, we're not subtracting anything. We're adding. I was adding the 2.5.
To double it, but your repeated addition is still multiplication, and look at the rule right here.
Oh yeah,
Is this addition or multiplication?
multiplication.
So then this would be multiplicative, which means it's also what?
It's also division, because multiplication and division.
Okay. If I make 0 cakes, how much flour do I need?
0.
What does that point right there tell me?
It's forgot the word.
What is 0, 0? What point is 0, 0?
The origin.
And if a line has a constant rate of change and goes through the origin, what kind of relationship is it?
Say pro. I can't remember the word.
Proportional.
Okay. Proportional.
Good. Okay, and that is done. And if for this example, if we were looking at it and we had cakes and we had flour, how much flour that we would use would depend on how many cakes that we make. So these would be my independent quantities. And what would my dependent quantities be? Dependent is always Y, so I'd have 2.5. I would have 5. What else? Ten and 0.
Oh.
And then Imagine Math will ask you to identify whether something is independent, dependent, or neither.
Yeah, that's what I'm doing right now. I don't understand it much.
So if you have equation,
Yeah.
this is going to be neither
Oh.
because it includes your independent and your dependent.
Yeah. Okay.
So I'm going to come back. I'm going to stop the recording.